In this BJT circuit, a DC voltage is applied to the base input and an AC signal is superimposed on that. So the total input voltage is VBE is equal to the DC part VBE plus the AC part VBE. We will represent the DC voltage in all caps and the AC voltages in all small letters and the total voltage in capital and small letters. Because of this input voltage, we will have a collector current IC, and we know that IC is equal to IS e power VBE divided by VT. We can replace this VB using the equation here. So IC becomes IS e power VBE plus the AC part of VBE divided by VT. This can be expanded into IS times e power VBE divided by VT multiplied by e power VBE divided by VT. But we know that this term is the DC part of the collector current. So we can write IC is equal to the DC collector current times e power VBE divided by VT. E power x is expanded as 1 plus x divided by 1 factorial plus x square divided by 2 factorials plus etc. If x is much less than 1, this equation can be approximated to 1 plus x, ignoring the square and other higher power terms. So applying that to this equation, IC will become IC times 1 plus VBE divided by VT. That means IC is equal to IC plus IC times VBE divided by VT. This is the DC part and this is the AC signal part of the IC. And this is valid only for VBE much less than VT. So that means the total current IC is equal to IC, which is the DC part, plus IC divided by VT times VBE is the AC part or the signal part. Just looking at the signal part, we can see that IC is equal to IC divided by VT times VBE. So this term is a conductance term which relates IC to VBE or which relates current to voltage. And that term is called the transconductance or GM of the transistor. By definition, transconductance is the derivative of the collector current with respect to the base voltage. If you look at the VBE versus IC transfer curve, you will see that the slope of the curve corresponds to the transconductance GM. The slope here is delta Y divided by delta X, which is delta IC divided by delta VBE. Or at the limit, this becomes the derivative of IC with respect to VBE, which is equal to transconductance by definition. In summary, we got a relationship that connects the small signal collector current to the small signal VBE input voltage through a parameter called transconductance. And we write that equation as IC is equal to GM times VBE. And we also found the formula for transconductance as the DC collector current divided by the thermal voltage. This applies only when the small signal input voltage VBE is much less than the thermal voltage, which is 25 millielectron volt.